Hello everyone, my name is Abhishek and welcome back to my channel. To the terms like IP address, subnet, CIDR range, OSI model often confuse you. Have you ever wondered how your mobile device connects to websites like google.com over the internet? How does the traffic flow from your device to the website and how these websites receive your request and send response back to you? Don't worry. If you ever had such questions, this networking fundamentals playlist is the answer that you are looking for. In this playlist, we will cover all the fundamentals of networking through basic examples that anyone can understand. All that you need to do is just watch these playlist videos till the end. Whether you are a DevOps engineer, data engineer, full stack engineer, networking fundamentals are very important to understand your organizational infrastructure or the application workflow. So without any further delay, let's start with the first video and the first topic that we have for today, that is IP address. IP address is a very simple concept. So IP address is used to generate or to provide a unique address to a particular device that is connected to your network. Don't worry, I'll make it simple. Let's say you have a home network. There is a house, and within this house, there is a Wi-Fi or local network that is created through a router. And there are two people or two persons living in this house, and each person has two devices. So overall, there are four devices that are connected to this local network or the Wi-Fi network. Now, what happened was one of these devices was used to connect to a payments website and made a payment. You want to track which of these devices was connected to this payment device, and you want to block access in the future. Probably also there is a kid in the house, and you might want the device that is used by the kid to access Instagram. Or you might want one person who is using this particular device to block access to youtube.com. Now, if each of these devices does not have a unique identification number, how can you do that? Right? It's practically not possible, and you will end up doing all these devices access blocked to these websites. So to avoid that, each of these devices should have a unique number, and that unique identification is nothing but IP address. It's not just about blocking access. Probably you want to track the activities of a particular device, or you want to monitor activities of a particular device. In all of these cases, IP address comes into handy. Now your next question should be, Abhishek, okay, I understood IP address is a unique number that is given to device. Let's say in my house, if there are four devices, each device gets a unique IP address. But my next question is, how does this unique address look like? So you said this is a unique address, but how exactly does it look like? So just like human beings have names, or houses have the house number, which are unique, right? Of course, human beings' names are not unique. But if you take about houses where you have a unique identification number for each house, so this particular representation is done through IPv4 for devices. There is also a standard called IPv6. We'll talk about it later. But for generating unique address for each device, the standard that is followed is IPv4. And using IPv4, you can generate huge number of unique addresses. Now, why is that required? You might say that, Abhishek, why do I need to follow this particular practice? In my house network, there are only four devices. So I can simply say one device as 1.1, one device as 1.2, third device as 2.1, and fourth device as 2.2. Now, each of them got unique identification. But what if there are 10 more devices that got added? Or instead of this house, let's take example of your school or your university, where there can be 10,000 or 20,000 devices that are connected to a particular number. So for each of these things, to maintain a proper standard, see, for your house, if you maintain this particular standard, so for your school and university, you have to create a different standard. So to maintain a proper standard, the one that is used is IPv4. So using IPv4, what you will do is you will generate a unique identification number in the format such as 172.16.3.4 or 10.1.2.4. So these are the IP addresses. That is, if you are using IPv4 standard, for your device, you will see addresses in this particular format. Today, you can go to your laptop and type the command called ifconfig or ipconfig, and you will see this kind of representations for your device. Now, these things are called as IP addresses. Now, let's try to understand what is the significance that you get when you assign this kind of numbers. So if you watch carefully, for each number, there is a dot, right? So here there is a dot, here there is a dot, here there is a dot, and here there is a dot. What is the advantage? So the advantage that you get is each of this number can vary from 0 to 255. So that means the number of unique identifications that you generate varies from 0 to 255 multiplied by 0 to 255 multiplied by 0 to 255 multiplied by 0 to 255. So this is the number of unique IP addresses that you can generate using IPv4 standard. Now your next question has to be, Abhishek, why 255? Why can't it be 0 to 1000? So with IPv4 standard, what you do is, of course, this is a number that you see, but for computer, it does not understand numbers. It only understands bits. So each of this number is 1 byte or 8 bits, right? So overall, what exactly is an IP address? IP address is nothing but 4 bytes or 32 bits. And each byte, right? 4 bytes, each byte is separated by a dot. So how does an IP address would look like? IP addresses would look like 0 to 255, 0 to 255, 0 to 255. Got it? So why 255? That is because in computer language, in IPv4 standard, you have 4 bytes and 1 byte is nothing but 8 bits. So 4 bytes is nothing but 32 bits. So overall, each of this number that you can see can be varied from 0 to 255 only. So this is a standard, you cannot change it. And this standard is called as IPv4, if I repeat one more time. Got it? So how does IP addresses look like? So tomorrow, if you create an EC2 instance or a virtual machine in Azure, what are the numbers that you would usually see? You will not see something like 600.400.150.10. This will not be possible. Numbers that you would see can probably be 192.168.12.14. Any number in all of these 4 places that is separated by dot should be varied from 0 to 255 only. I know I'm repeating this multiple times, but I want to make sure you all understand how the IP address is represented. It is only represented between 0 to 255. That is because in computer language, IPv4 represents IP addresses in 4 bytes, and each of the byte, right? Each of the 4 bytes is nothing but 8 bits, right? And how are these 8 bits represented? If I have to write this IP address, I have to write 32 hyphens, for example. Okay. This is 1, 2, 3, 4, 5, 6, 7, 8. This is 1 bit. 1, 2, 3, 4, 5, 6, 7, 8. This is another bit. 1, 2, 3, 4, 5, 6, 7, 8. This is another bit. 1, 2, 3, 4, 5, 6, 7, 8. This is another bit. So this is byte 1, byte 2, byte 3, and byte 4. So this is how IP addresses are represented. Now, when I say 192, what happens is, how does computer understand this 192? Computer understands this 192 as 1, 1, 0, 0, 0, 0, 0, 0. Now, how did I write this particular thing? That is very simple. For each byte, each bit that you see here, you start with 0, you call it as 2 power 0. This is 2 power 1. This is 2 power 2. This is 2 power 3, 2 power 4, 2 power 5, 2 power 6, and 2 power 7. Because the first number is 192, 2 power 7 plus 2 power 6, that is 128 plus 64, which comes to 192. This is how computer understands your IP address. The reason why, maximum number that you can see here, right? If you want to see here, even if you put 1, 1, 1, 1, 1, 1, 1, computer understands this as 2 power 0 plus 2 power 1, 2 power 2, 2 power 3, 4, 5, 6, and 7, which combinedly comes to 255. That's why maximum number in an IP address can be 255 only. If you see something like this, 192.600.12.254, this is not an IP address because 600 is not possible. Now, I hope it is very clear how IP address is represented in the IPv4 format. Now, if you want to try out few IP addresses, you can give it a try. Like, your assignment can be convert this particular IP address, that is 172 probably dot 32 dot 16 dot 1. Convert this IP address into the format that I have explained. That is using the bits format. How does computer understand this particular IP address? So to do this, what you will simply do, you will convert each byte into 8 hyphens. You will write 2 hyphens, and under this 8 hyphens, you can write 2 power 0, 2 power 1, 2 power 2, 2 power 3, and convert this particular thing. Let's say if I have to write this, by default, I know 32 is just 2 power 5. So this is first decimal, second decimal, third, fourth, fifth, sixth, seventh, right? If I have something like this, in the fifth place, I'll just put 1, and in all of the places, I'll put 0, right? So this is how IP address is converted in the hexadecimal or octet format. It's octet format, it's not hexa. So this is how number is converted into octet format and how computer understands the IP address. Perfect. Now you will understand later point of time why I'm stressing so much on this particular representation. When we try to understand subnets and CIDR, this comes very, very handy. So I hope IP address part is clear. Now let's move to the next concept, that is subnet. Now, Abhishek, IP address is very clear, where let's say if I have a home network or a school network, and within the school network, what I'll simply do is I will say I just need some, whenever I'm creating this particular network, let's say I'm creating a VPC on AWS, or I'm creating something on OpenStack. Okay, so I'm requesting the network provider, let's say some 65,000 IP addresses, and I got 65,000 IP addresses. I know the maximum people that would connect to my network, if it is a school network or office network, maximum people that would connect to it is only 40K. So I've just taken 25K IP addresses as a space. So I know, okay, this amount cannot be exceeded. Now I'll create a school Wi-Fi or office Wi-Fi, right? Let's call office Wi-Fi, and we will call this office Wi-Fi as free Wi-Fi because anyone can connect to it. So any new employee that is joining this company has started accessing this network, right? This person, this person, this person, everyone has started accessing this free network. Now, what happened one day was there is this employee who accessed a malicious website. Okay. So this person has accessed a malicious website that was written by a hacker. And because this person has accessed it, hacker got access into this particular device. And now if you understand carefully, all of these devices are connected to the same network. That means hacker got access to one device, but because they are connected to the same network, hacker can access all the devices, right? So technically all the devices are hacked. Now, if this is your office network, there can be some sensitive files, or there can be payroll of the employees, or there can be some financial data of the company that are stored in some servers, such as your bank details or any such thing. So hacker got access to everything. So your complete company network got hacked. Now this should not happen, right? Of course, this should never happen. So there is a concept in networking which is called as subnet. What exactly is this concept of subnet? Very simple. Subnet is basically, if you look at the name itself, it says sub networking, where if you take the same example, you can create a VPC in AWS, or you can create a new network on your OpenStack with 65,000 IP addresses. And what you will simply do is you will say, out of this 65 IP addresses, okay, or out of this complete network, I will split it into two parts, okay? And one network I will use only for finance related things, all the sensitive information of the company. I will call this network as secure network. Like sometimes if you go to your company, or if you go to your school network, you will see some secure networks which you don't have access to. And then you will have some free network, or this network can have a password, but this will be shared. If you are an employee, you just go to your admin and you ask for a password, and they will share this password with you. So I'll call it as a free network. And so I will try to split this network into two parts. And I will say network one should be strictly used by finance team, and network two can be used by anyone. Now, even if the hacker, one of these people, tries to access a malicious website and hacker gets access to it, all the devices in this particular network are compromised, but still all of these are sensitive. This is important for the company. This concept is called as subnetting. And this particular network is called as subnet, and this particular network is called as subnet. Why are they called as subnets? Because they are part of a bigger network and you have tried to split it. So that's why you call it as subnet, right? Understood the advantage of creating a subnet? The advantage of creating a subnet is you get security, you have the privacy, and you have a proper isolation. That's why subnets are used. Today, you can go back and you can create subnet in your home Wi-Fi network as well, right? You can say only the heavy usage appliances should use a particular subnet, and other appliances should use a different subnet. That's totally possible. You can create subnets in any kind of network, right? So this will give security, privacy, as well as isolation. Now, I'll come back to the concept of subnet addresses, like how subnet 1 gets IP addresses and how subnet 2 gets IP addresses. But before that, just understand that there are two types of subnets. One is private subnet, two is public subnet. If you ever used a cloud provider, you might have heard about these terms called private and public subnet. But what exactly are these? So private subnet is some network that does not have access to internet, and public subnet is a subnet that has access to internet. That's the only difference. It's a very simple difference, right? So private subnet has access to does not have access to internet, and public subnet has access to internet. How do you do that? How can you enable access to internet? Don't worry, it's a very simple concept. If you already know about cloud providers like AWS or Azure, all that you need to do is you can go to this particular subnet and you can attach route tables to this particular subnet, and destination of a particular route of this subnet you can provide as an internet gateway, and that will grant access to the internet. Even if you don't know this particular concept, you can ignore for now, because right now we are learning the fundamentals of networking. So just understand access to internet, public subnet, no access to internet, private subnet. Now let's go back to the concept that I was explaining, right? Abhishek, you mentioned in the last slide in a very simple way that you have a office network, right? And in the office network, you said you will simply split finance and free subnet where everyone can join. You mentioned it as very simple way where there are 65 IP addresses, but how do you actually know how many IP addresses this finance subnet gets and how many IP addresses that this particular subnet gets, right? Overall, when you created this VPC in AWS, you have requested for 65,000 IP addresses. What is VPC? VPC is just nothing but a private network. So you have requested for a private network from AWS and you said you need 65,000 IP addresses. Now you are saying you will create two subnets in the 65,000 IP addresses. One is finance and two is a free subnet. Everyone can access. But how will you say that this finance subnet, let's say it only needs 256 IP addresses and this need rest all IP addresses? How will you divide that? It's very simple. Again, wherever you are creating this subnet, right? So if you are creating on private cloud, you have platforms like OpenStack. If you are creating on public cloud providers like AWS or Azure, in any of the cases, whenever you are creating this subnet, you will be asked to provide a CIDR range. This is also called as CIDR. So this CIDR or CIDR is a way of explaining how many IP addresses are available in a particular subnet, right? Here I want to say my finance particular thing just needs 256 IP addresses and rest all can be given to this free subnet where anyone will access this particular network. Now, how will you do? CIDR is the solution. How does CIDR work, right? So concept of CIDR is very, very simple. Don't worry, I'll explain it in a very simple way. People usually find it difficult, but the calculation is very simple. So what you will do when you create this particular subnet, let's use AWS as an example. So you will go to AWS and you will say, I want to create a subnet. Of course, you need to go to the VPC first, right? This is the VPC that you have initially created. You will go to this VPC. Inside the VPC, you'll go to the subnet. And within this subnet, what you will do, I mean, you are creating this subnet. When you are creating, you will be asked for a CIDR. And when you want to create this CIDR, the simple solution is you say 172.16.3.0/24. So if you require 256 IP addresses, you will provide -24. Now, how did I do this? Right? This should be your $1,000,000 question. That is, Abhishek, how did you understand if I need 256 IP addresses, I need to provide 176.16.3.0/24 or 192.16.4.0/24, whatever is the IP address of the VPC followed by /24. How did you understand this? It is very simple. Again, like I mentioned, you pick up any IP address in the VPC range. Okay, let's say while creating VPC, you have provided the range as 172.16.0.0. Pick up any IP address. I mean, you said the VPC IP address range should be 172.16.0.0 to 172.16.255.256 255. That is, you have 65,000 IP addresses. Now pick up any IP address. So let's pick up 172.16.3.4. Let's take this as an example. And as I've told you, represent this in the octet format. That is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And finally, 1, 2, 3, 4, 5, 6, 7, 8. Right? So I am representing this particular IP address. You can pick up any IP address. I am representing this particular IP address in the IPv4 byte standard, where for each byte I have written the bits. So overall, if you combine, here there are 8 bits. Here there are 8 bits. Here there are 8 bits. And here there are 8 bits. So if you combine all of these things, what is the output? 32 bits. Right? And as I have mentioned you, each of this particular thing can represent only between 0 to 255. And I have mentioned I just need 256 IP addresses for the finance domain. So only this last thing is enough, right? So if I just provide 172.16.3.0 to 172.16.3.255, I got my required 256 IP addresses. So I don't need this 8, this 8, this 8. That means this 8 can be common, this 8 can be common, this 8 can be common. Only this thing will vary. So what was my VPC IP address? VPC IP address was 172.16.0.0 to 255.255, right? So all these three things can be common for my device. So this can be the host network or the common things, and this has to vary. So that's why I'm providing 172.16.3.0/24. Why 24? Because I've cancelled 24. That is, all this 24 bits can remain static, can remain same, and only this 8 bits have to vary. So that's why I said 0 followed by 24. Don't worry, I'll try to explain it one more time if you did not understand. So what was my VPC IP address, or the primary network address? 172.16.0.0 to 172.16.255.255. This was my IP address range, right? Now, if I just need 256 IP addresses, I can pick up something like 172.16.3.0, 3.1, 3.2, 3.4 to 3.255, right? What are the number of IP addresses here? 256 IP addresses, right? So this solves my problem. Either I can pick 172.16.3.0 to 3.255, or 172.16.4.0 to 4.255, 5.0 to 5.255. Anything solves my problem. So what I can simply do is, if I need 256 IP addresses from this particular VPC range to provide to the finance network thing, either I can use 172.16.3.0/24, 4.0/24, 6.0/24, or even 244.0/24, right? I can provide any of these things as the CIDR range for my subnet. Now, let's make it even more simple. Let's say, right, this is my office network, and here same, I want a finance domain, finance subnet, and this is my free subnet. And in the finance subnet, I just want 2 addresses, nothing more than that. I just want 2 addresses. And here, right, here I want to provide rest all addresses for the devices that are getting connected. So if I just need two addresses, what I can simply do is I can provide 172.16.3.0/31. Why 31? So if you remember the hyphens thing, there are 32 hyphens, right? Out of which I have cancelled 31 hyphens. So there is only one hyphen left. And one value of a bit is nothing but it can be either 1 or it can be 0. So there are two IP addresses that are generated. When you are calculating the CIDR thing, right, you should not calculate from 2 power 0. So if you have 32 and out of which 31 are striked out, so there is only one that is left. So always try to calculate 32 minus the number that is provided here. If 31 is provided, 32 minus 31 and 2 power the number that is left. So here 2 power 1 is left. So the answer is 2. So similarly, if we are taking 24 here, 32 minus 24, what is left? 8. What is 2 power 8? 256 IP addresses, right? So if you just want, let's say 32 IP addresses, what you will do? 32 minus 27 is 5 and 2 power 5 is 32. So I can simply provide here 27. So depending on this particular calculation, you will take the CIDR range. So if there is a IP address like this, right? So if there is some IP address like subnet with CIDR range like 10.0.0.0/8. What does that mean? 32 minus 8, which is 24. So the number of IP addresses is 2 power 24, which is almost like, I think, a very huge number, right? 256 into 256 into 256. So that's a very huge number, 2 power 24. So whenever you are seeing something with /8, which is nothing but it is also called as class A IP addresses. And if you are seeing something with /16, which are called as class B, when you see /24, which is called /C, here you just have 256 IP addresses. Here you have 256 into 256. And here you have 256 into 256 into 256. This is just a common representation. Don't worry, most of the times you will see /8, /16 and /24. But along with that, you might see /27, you might see /28, you might see /29 as well. Whenever you are seeing something like this, don't get panicked. Just simple thing that has to come to your mind is 32 minus 27, which is 5. So number of IP addresses is 32. When you see 29, 32 minus 29, which is 3. So number of IP addresses is 2 power 3, which is 8. Very simple calculation and straightforward, right? So this is the thing that has to be in your back of mind. So next time when you create a VPC, observe these things carefully. Or you are on OpenStack, you are on Azure, anywhere, whenever you are creating a new network, okay, it will immediately ask you for the range of that particular network. So let's say when I'm creating VPC, it will initially ask me for a range. And range I can provide, like I told you, either 10, 172, 198, anything. So I'll just say 192.16.0.0/16. That is, I will have 65,000 IP address. And now when I create subnets inside this VPC, depending on the requirement from the development team or depending on the requirement from the team, if they are asking 32 IP addresses only, what I'll simply do, I'll say 192.16.3.3 or 4, anything here, 3.0/27. This is what I'll give you. And why I'm doing it very quickly? Because I'm very used to this particular calculation. So you can take few calculations as example. In internet, you just search for CIDR calculators, you will get hundreds of it and verify if your calculation is right. So tomorrow, if someone is asking me that Abhishek, this is my VPC and I want to create a new VPC, subnet with 64 IP addresses. I just want subnet with 64 IP addresses. Immediately what I'll do is I'll just, okay, look at this IP address, Randomly, I'll say 192.16, whatever is my favorite number. So I'll just say 5.0 slash, okay, 64. This is 2 power 6. So 32 minus 28, sorry, 26 is 6. So 2 power 6 is 64. So I'll just say slash 26, right? Now, why I'm only modifying this particular number? Because they are asking below 256. So below 266, I'll just modify this particular thing. This will be static. I'll just put this as 0. If they're asking more than 256, let's say someone is asking me 65,000 IP addresses. So what I'll do, 192.16.0/0/16. This is the CIDR range that I would provide. Now I hope these examples made the concept of CIDR clear to you. And what you will do is go to the CIDR calculator on internet and take random numbers like this and try to estimate what will be the CIDR number for it, or what will be the number of IP addresses for it. I can give you some assignments. What is the number of IP addresses for this particular CIDR range? Okay, let me write in a new one. What are the number of IP addresses for this particular CIDR that you see? 172.168.3.0/30. And what is the CIDR for 10.0.0/8? So in the comment section, you can mention what will be the number of IP addresses for both of this CIDR range. Let me see how many of you can get this right. And before we move to the next topic, there is one more thing that you have to remember. Most of the times when we talk about private subnets, you will see these numbers only: 192, 172, 10, right? Why you would see mostly these numbers is because these are the ones that are used for private subnets. Okay, so this is just like a practice. So even with Amazon or wherever you are creating, you would see these numbers as the starting ones when you create private subnets, because these are the numbers that are used for private subnets, right? So when you are creating a private subnet, your CIDR range cannot be 3.4.5.6 or 5.0/24. This cannot be your thing, because probably this public one of these public IP addresses has been taken by some particular website. For example, 8.8.8.8 is a public IP address that is taken by google.com. This is the DNS for the google.com. So if you keep this for your application, there will be a conflict. So anytime private IP addresses should be starting with this only, right? So I hope this concept is clear. So what did we cover till now? Till now, we covered the concept of IP address. We covered the concept of CIDR. We covered the concept of subnet. Within subnet, we try to cover what is private subnet. We try to cover what is public subnet as well. These are the things that we have covered till now. And the next concept is about ports. Ports is again a very, very simple concept. You don't have to get confused with it. So whenever we provide IP addresses to connect to websites, we provide some ports, right? Colon 80, colon 443, or we say colon 3600, or colon 8080. What exactly are these things? So basically, to bind an application. So let's take a virtual machine. Okay. On this virtual machine, I have deployed an application. Okay. Now on this virtual machine, there can be number of applications. Okay. So what you can do is, for application, you can provide a unique port. Again, ports are also in a particular range only. You cannot create port with number 1 lakh, right? So, and there are some ports that are taken also, right? For example, there is a specific port for MySQL. Better not to take that particular port. Or there can be a port for Jenkins. Usually Jenkins starts on 8080. So better not to take that particular port. So whenever you are starting your application, start with unique ports such as 9000, right? Or you can take 9191, these kind of ports, right? For example, better not to take ports like 3306, which are taken by other kind of applications. So these things comes with practice. And you know what, if you go back to the topic that we are discussing, whenever you create application on a virtual machine, to access this application from the internet, you need two things. One is the IP address of this virtual machine. Of course, if it's a public IP address, only you can access it from the internet. If it's a private IP address, you can access only within your network. Let's say this is a public IP address. So to access this particular application, if this application has port 9191, so you will say 172.16, sorry, public IP address, let's say 3.4.5.8 colon 9191. Now, if this application has port 5162, so you will access using 5162. So what is a port? Port is a unique number for your application. In an instance, there can be hundreds of applications, and using port, you can distinguish the request has to go to which particular application, right? So till now we covered these four concepts, and there is one concept that is left, that is OSI model. And when we learn about OSI model, we will cover things like HTTP, we will cover TCP, we will cover layer 1 to layer 7. And this is going to be a huge topic. So let's try to put this in the part 2. So if you reach to this particular point of the video, you will realize OSI model will be taken care in the part 2. So this is the next video of this playlist. And the reason why I thought of doing it in a playlist is because if we have more requirements, or if there are more questions on a particular concept, we can cover them as part of this playlist, right? So this is the concept for today. I hope you liked it. And let me know in the comment section, how did you find the concepts such as IP address, subnet, port, and CIDR block? See you all in the next video. Take care. Bye bye.